This is the first video in the Test 4 review, and it covers material on law of sines and law of cosines. So before we start on our example problems, I just want to give a quick review of what our law of sine and cosine is. So our law of sines states that A over sine A equals B over sine of B, which equals C over sine of C. Now remember, alternatively, this can also be written the other way around, so you could say that sine of A over A equals sine of B over B, which equals sine of C over C. For our law of cosines, we have a few equations that we can use. We know that A squared equals B squared plus C squared minus 2BC cosine of A. And so this can be rewritten for a few, like in various different forms. So we know that B squared equals A squared plus C squared minus 2AC cosine of B. And similarly, C squared equals A squared plus B squared minus 2AB cosine of C. So keeping these laws in mind, we're going to go through and do some example problems using the law of sines and law of cosines. So in this problem, we're told that side A equals 400 meters, angle A equals 42 degrees and 48 minutes, and angle C equals 22 degrees and 32 minutes. So, and we want to find the remaining sides and angles. So in solving these problems, it's often useful to start with just drawing our triangle and figuring out what we know and what we don't know. So we have this triangle. We have angle A, B, and C with corresponding sides: A, which is 400 meters, B, and C. And we know what our angle A is, and we know what our angle C is. So we have 42, 48, and 22, 32. So we know that the degrees in a triangle have to sum to 180, so finding angle B would be pretty easy. We just need to do 180 degrees minus 42 degrees 48 minutes minus 22 degrees 32 minutes. So if we do the math for that, that is going to give us 114 degrees and 40 minutes as our angle for B. So remember, in this problem, what we need to find is we need to find angle B, side B, and side C. So we found our angle B at 114.40. So because we have our side length A, we can just go ahead and use our law of sines to determine the rest of the side lengths. So we know that B over sine B equals A over sine A. So again, we have one side measure and we have all of our angles. So it's going to be convenient to use law of sines. So B over sine of 114 degrees 40 minutes equals 400 over sine of 42 degrees 48 minutes. So B is going to equal sine of 114 degrees 40 minutes times 400 over sine of 42 degrees 48 minutes. If you plug that into a calculator, you're going to get B is equal to approximately 535 meters. So 535 meters. So we can go ahead and use the law of sines to solve for our side C, and then we'll be done with this problem. So we know that C over sine C equals A over sine A. So we plug in what we know. So we know that C over sine of 22 degrees 32 minutes equals 400 over sine of 42 degrees 48 minutes. So that means that C is equal to sine of 2232 times 400 over sine of 4248, which puts C at approximately 226 meters. So we used our knowledge that there's 180 degrees in a triangle to find our remaining angle, and then we used law of sines to find the remaining sides B and C. In this problem, we're asked to solve the triangle with side A equal to 6.87 meters, side C is equal to 8.52 meters, and angle B is 33.2 degrees. So again, we're just going to start by sketching a triangle. That could be the triangle we're working with. So we have side angle A, B, and C with corresponding sides A, B, and C. So we're given a side angle side triangle, right? Because we know side A, angle B, and side C. So we can use the law of cosines to solve for our unknown side. So we're looking for side B. We know that B squared is going to be equal to A squared plus C squared minus 2AC cosine of B. So we can plug our values in. So B squared equals 6.87 squared plus 8.52 squared minus 2 times 6.87 times 8.52 times cosine of 33.2 degrees. So B is going to equal the square root of all of that we have above. If you were to plug that into a calculator, you're going to have 4.6724 approximately as our remaining side. So we have all of our sides. We just need to go back and find the rest of our angles. So we can do that using the law of sines. So we know that sine of A over A is going to be equal to sine of B over B, and then similarly to solve for sine C, we know that for angle C, we know sine C over C would be equal to sine of B over B. So this is just going to be a simple matter of plugging in our values and solving, and if we do that, we end up finding that A is equal to approximately 53.6 degrees, and from there we could just subtract 33.2 degrees and 53.6 degrees from 180, and we'll find that C is equal to approximately 93.2 degrees. In this question, we're asked to find the area of triangle ABC given that side A equals 11.3 meters, side B equals 6.5 meters, and side C equals 12.2 degrees. So typically we would know that the area of a triangle would be 1/2 base times height. However, we can rewrite some of these formulas using the things that we know about sine and cosine. So we could also say that area equals 1/2 BC sine of A, or 1/2 AC sine of B, or 1/2 AB sine of C. So basically you can remember those by knowing whichever side isn't being multiplied in front of your sine is going to be the angle that you find after your sine. So here we have AB leaving C, or AC leaving B, or BC leaving A. So we're given sides AB and angle C. So our best bet to find the area would be to use this third formula we have here. So we can say that area is equal to 1/2 11.3 times 6.5 times the sine of angle 12.2 degrees. If we were to plug that into a calculator, we would get the area of the triangle to be approximately 7.8 meters squared. Okay, so this is a word problem, and these can get a little tricky, but so basically Jan and Jim start hiking from the same spot at the same time, with Jan going at 2 miles per hour north 25 degrees east, and Jim going 3 miles per hour north 37 degrees west. And so we want to know how far apart they are after 4 hours. So the best thing to do with this kind of problem is start off by drawing a triangle. So let's just say that this is north, right, this dotted line here. So we know that Jan went 2 miles per hour north 25 degrees east, so she's 25 degrees east of north. And she went at 2 miles per hour, so after 4 hours she would have gone 8 miles. And Jim went 37 degrees west of north, so that would be 37 degrees, and after 4 hours he would have gone 12 miles since he was going 3 miles per hour. And so we want to know how far apart they are from each other. So we have this angle A, which would be 25 degrees plus 37 degrees, which is equal to 62 degrees. And we have our side 12, our side 8, and we're looking to find this side up here, A. So let's just say that this angle is B and C, so 12 is side B and 8 is side C. So we have two sides, B and C, so B equals 12 and C equals 8. We have angle A, which equals 62 degrees, and we need to find what side A is equal to. So in order to do this, we can use our law of cosines. So we know that our side A squared is going to be equal to B squared plus C squared minus 2BC cosine of angle A. So we'll take the square root of that to find our side A. So A equals the square root of B squared plus C squared minus 2BC cosine of A. So I just need to make a little room for this. We're going to say so A is equal to the square root of 12 squared plus 8 squared minus 2 times 12 times 8 times the cosine of 62 degrees. So if we put that into a calculator, we would find that A is approximately equal to 10.9 miles. So after 4 hours, Jan and Jim are 10.9 miles apart. So just as a summary, this video worked with law of sines, which is just variations on A over sine A equals B over sine B equals C over sine C, as well as law of cosines, which is just variations depending on what information you have of A squared equals B squared plus C squared minus 2BC cosine A. And so the most important thing when you're solving these problems is you're going to want to start off by drawing your triangle. And if you do that, you should be able to just fill in, figure out, all right, I know A, I know B or C. Angles A, B, C, and you're looking for side A or B or C. So if you draw your triangle, label it properly, and figure out what you know, you should be able to accurately determine whether you need law of sine or cosine, and then you know what to plug in and how to solve for your value. So this is the end of the first video for the test 4 review, and there's more problems that you can practice using law of sines and cosines if you go on my math lab and look at the test 4 customized review.